All right. So if you look at this problem right here, let's go ahead and get you guys started. You will see several things in this problem, several numbers, right? So let's read it. Forensics recovered a syringe containing 0.250 grams of an unknown gas at a pressure of 1.05 atm and a room temperature of 298 Kelvin. The gas occupies a volume of 0.125 liters. Calculate the molar mass. All right, so I just gave you everything you need to know in order to solve this problem. Only thing you have to do now is plug in each variable. So if your formula here is given, molar mass, that's the big M right there, for molar mass. It's the little m for the mass, R, which is the gas constant, T, which is the temperature, divided by the pressure and the volume. You just have to plug in each of those numbers, all right? Just plug in each of your numbers to identify what you're looking for. So the 0.250 grams is for the M, so I'm putting that in there now. The gas constant, this was given to you all up above right here, okay? This number right here. So that's what we're going to use down below, okay, each and every time that we have to do a problem of this nature. All right, so now I'm just going to plug in the numbers into the identifying pieces here. And what I want you all to do, again, is to do these problems with me. Temperature was 298 Kelvin. Again, y'all, all of my problems are going to be in Kelvin. I do have the degrees Celsius right beside it, but FYI, if your professors don't give you the temperature in Kelvin, you just have to know to add 273 to the number in order to get that, all right? Divided by pressure, 1.05 atm, and then your volume was 0.125 liters. You also want to make sure that your volume is in liters so that you can cancel it out with your gas constant unit as well. So what we're going to do now is cancel out the units that we do not need anymore. And if it's a unit on the top, cancel it out with one on the bottom. Unit on the top, one on the bottom. Unit on the top, bottom. So that way you're able to identify what you no longer need. All right. So now, yes, Daisy, if your teacher gives you, right, there is a list of gas constants, the R constant. You pick the one based on the pressure. The pressure unit is the one that will tell you which gas constant to use because they're all different. Speaking of which, here, I'm going to show you. I'm glad you asked that question. So I can show this to you right here. So, well, this is not the one, but the gas pressure units will tell you which one to use. I think that's on my other set of notes, but yes, it's based on your gas pressure constant. Now, just plug these numbers into your calculator, guys. 0.250 times 0.0821 times 298. Now, you can write all of that down. You can write everything that's on the top once you multiply that, right? Then you can divide by the bottom number. I just like to go ahead and divide everything out so that I don't have to worry about that anymore, but you do whatever works for you, okay? And now, right here, you get 46.6. So, yep, 46.6 is the molar mass. Now, it did not tell us to identify this, but guess what? You wouldn't be able to identify this anyway because we don't know what this makes up. It could be any type of gas. It could be, 2 nitrogens and 3 oxygens, but we don't know what the 46.6 gas is unless we had a chart that we can just pull from. Now, as you can see here, I am underlining or highlighting the units that were left over that we did not cancel out. And this shows you pretty much why, this shows you why the final units are what they are. So this is the first, we're now on number 2, okay? We're on number 2, and it says, a portable medical oxygen cylinder has a volume of 2.5 liters. Let's go ahead and highlight the things that we already know that are given to us in the problem. So they're giving us a volume of 2.5 liters and is pressurized to 150 atm at 25 degrees Celsius, which is equal to 298 Kelvin. And then they're giving us the molar mass, which is going to save us some time because they want to know how many grams of oxygen are stored in this tank. Now, since you are looking for the grams and they gave you several different variables, you're going to have to rearrange this formula here to solve for the N and then convert the N to grams. All right. So we're going to do that right now. And I want you guys to pay close attention to how I go about solving for the N. I'm going to rearrange this formula, and I'm going to say that N equals to PV divided by R over T. Now, what you're going to see is that when you go back up here for your N, for your moles, okay, you'll see that there is some connotation here with the moles right there. But I want you all to know that the main formula you will use for your moles will be this one right here, okay? Because they are giving you 4 numbers that you have to follow. The pressure that they gave you, all right, was 150 atm. So I'm going to plug that in first. And then the volume that they gave us was 2.5 liters. And then on the very bottom, they gave us, well, you have to know to use that gas constant from up above. And then your temperature is 298 Kelvin. Now, they told you this was oxygen gas, so you're going to use that molar mass later, all right? You're going to use that molar mass later. Yes, Daisy, that is the correct formulas for what you noted in the comment box, yes. Now, as we go through our problem, let's go ahead and get rid of the units that we no longer need so that we'll know that we are on the right track for what we're solving. All right, so as you can see, I'm knocking everything that I don't need. What do I see that's left over in terms of my units are my moles. So that's what I'm going to be looking for in this answer. So we have set up the problem correctly. Now the only thing you need to do is go in and plug the numbers in. Okay, so let's go ahead and type in the 150 atms times 2.5 liters. You get that top number. Then I'm going to divide that by 0.0821. I'm going to divide it again by 298. And I get 15.3. Well, actually 15.3. But if we go by our sig fig numbers, 15.3 will actually become 15 because we only need 2 significant digits. Now, they're asking us to find how many grams. If we go back up here, they're looking for grams. So you're going to take that 15 moles of oxygen and you're going to multiply that times your molar mass that they already provided you with in the problem. All right. And then divided by 1 mole of oxygen. And now you're just going to cancel out your units that you no longer need and plug that into your calculator. So 15 times 32.00 gives us 480. So we did all this work to give us 480 grams of oxygen. All right. Customs agents intercepted a balloon filled with a